Assalamualaikum. My name is Kalisa Ashachalimete Zulkifli, and my matrix number is AA201096. So in this video, I would like to show you how I set up this experiment step by step and show you how this going. So let's check it out. Before we start this experiment, we need to prepare all the material needed. The first thing is book as a round, Lego as a height of round, measuring tape, paper and pen to record all the data, and the most important thing is toys card.
Okay, so let's do the experiment. The first thing is put the Lego under the book and put toys car on it. After that, measure the distance moved beyond the round. After that, record it on the book. Repeat this step for second try. And repeat it again for third try. Repeat this experiment until reach the maximum height.
So from this picture, it shows the different distance between each height. So here, all the data have been recorded. That's all from me. Thank you.
Hi and Assalamualaikum. My name is Atika Liana binti Muhammad Muzani. My metric number is AA200797. So, I'm going to talk about the filler table. The filler table is about the facts, ideas, problems, and solutions to solve the task given. The first fact is about the distance traveled by car is depend on the height of the ramp. The problem for the first fact is how to study the relationship between the distance traveled and the height of the ramp. So, the solution for the problem is by controlling the ramp's height and ensuring that the ramp's length is constant. Keep track of the car distance traveled. The second fact is the increment of ramp height consistent with 10 data, which is the variable that will be manipulated in this experiment. The problem for the second fact is what is the increment of ramp height used in this experiment. So, the solution for this problem is by starting the ramp height at 2 cm and increasing by 2 cm until reaching 20 cm, which is the maximum height. The third fact is the value of ramp length that will be a constant value in this experiment. So the issue for this fact is how to set the ramp length on the same value and what is the value for the ramp length. The solution is by using the same ramp, which is 32.5 cm for all the increment ramp height until reaching the maximum height. The fourth is to calculate the mean travel by the car, which is the average distance. The issue is how to calculate the mean travel by car. So the solution is to repeat the steps for 3 times and record the data and calculate the mean by using the formula T1 plus T2 plus T3 over 3. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Dina Nurashahani binti Arshad and my matrix number is AA200252. Now I would like to provide the answer for question number 1. In question number 1, we have to draw a scatter diagram for the mean measured distance traveled by the toy car versus the height of ramp.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Sarah Patricia binti Muhammad Kamaruzaman and my matric number is AA201309. The scatter diagram exhibits a linear relationship between the height of ramp and the distance traveled by toy car. It can be proved when we increase the value of x, the value of y will increase too.
Assalamualaikum. My name is Siti Nafalana binti Muhammad Sri. I want to answer for the question 3. The question 3 is calculate the linear correlation coefficient for the data and interpret the given answer. Okay, so for the first step is you must do the 5 table. Okay, the first table is value of x. The second table is value of y. And the third table is value of x squared. And the next table is value of y squared and the last table is x multiply y. So the value of x I use the height of ramp and the value of y I use the means of distance traveled by the toy car. Okay. So for the calculate the correlation coefficient, we use the formula correlation coefficient R equal SXY divides square root SXX multiply SYY. So for calculate the SXX, we use the formula SXX equal summation x square minus summation x yang di square divides n. So SXX equal 1540 minus 110 square divides 10. So we got 330. So for the SYY, we use the formula SYY equal summation y square minus summation y d square divides n. So we got SYY equal 74675 minus 769 square divides 10. So we got 15538.9. So the last is x multiply y. So we use the formula xxy equal summation xy minus summation x summation y divides n. So SXY equal 10694 minus 110 multiply 769 divides 10. So we got 2235. So for calculate the correlation coefficient, we use the formula SXY divides square root SXX multiply SYY. So 2235 divides square root 330 multiply 15538.9. So we got 0.9870. So correlation coefficient equal 1. So we got perfect positive correlation. That's all for me. Thank you.
My name is Neha Anna Pompat Sivakumar. My matrix number is AA201362. I'll be explaining question 4, which is to use the least square method to find the regression line. To calculate the equation to find the regression line is y equals BO plus B1 times X. To find B1 is representing the gradient of the line, whereas B0 represents the y-intercept. To find B1 is SXY divided by SXX. uh, according to the formula, which is the sum of x square minus the sum of x to the power 2 divided by n, you can get the value of sxx, which is 15538.9. To find sxy is sum of xy minus the sum of x times sum of y divided by n. N is 10. So the total value of sxy is 2235, and b1, to find b1 is 2235 divided by 15,538.9. You will get 0.1438. Next is to calculate b0. To calculate b0 is y minus b1 times x. Y equals a sum of y divided by 10. So the sum of y is 110, as can see according to the table. 110 divided by 10 is y equals to 11. So next, after getting 11, we need to find the value of x. Sum of x is to find the value of x, sum of x divided by n. The sum of x is 769, and then divide it by 10, you can get the value of x, which is 76.9. So b0 equals 11 minus 0.1438, which is b1, times 76.9. You will get negative 0.061. That is the value of b0. So the equation of the regression line is y equals 0.1438 x minus 0.061. The next thing to do is choose two random x numbers and then find the value of y using that equation, and then is to sketch the line of regression onto the graph. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Adrana Nazura binti Nur Azwan, and my number matric is AA200699. So I would like to present the solution of question 5. The question 5 is predict the value of the mean measure distance traveled by toy car when the height of ramp is 200 cm. That's mean 200 cm is the value of x. We have got the regression line before this in question 4. So we just need to enter the given value x, which is 200 cm, into the equation. The regression line is y equal to negative 0.061 plus 0.1438x. Then y equal negative 0.061 plus 0.1438 times 200 equal to 28.70 centimeter. The answer for question 5 is 28.70 centimeter. That's all from me. Thank you.
Now, I'm going to explain the discussion for this experiment. The main objective for this experiment is to investigate the relationship between the height of ramp and the distance traveled by the toy car. The scatter diagram that I've shown before shows that it exhibits a linear relationship between the two variables, because as the value of x increases, the value of y will increase too. From the diagram, we can interpret that it is a positive correlation, and 90% of variation y can be explained by x. The linear correlation coefficient for the data is R equals to 0.987, which indicates that there is a strong relationship between the height of ramp and the distance traveled by the toy car. The least square regression line for the diagram is y equals to 0.1438x minus 0.061, with the value for B0 is negative 0.061 and the value for B1 is 0.1438. By using the estimated regression equation that I've stated before, we found that when the height of the ramp is 200 cm, the mean measured distance travelled by the toy car is 28.70 cm. As a conclusion, we can predict a value of dependent variable at certain value of independent variable. It is important to make sure that the estimation for dependent variable is more accurate. By using linear regression for this experiment, we can obtain the trend for the distance travelled by toy car when height of ramp is increased and the distance travelled by the toy car at the given level of height ramp. That's all from me. Thank you.